our charge was to talk about our own journey into where we are now, into our neuroscience of addiction. So I immediately learned how to drive a car, and 2 weeks into it, I drove myself over the railroad track to Memphis State University, saying, here I am, and registering to take classes in the psychology department. I had a degree, a BA, a bachelor's degree in psychology in Tel Aviv. If you can, choose your mentors wisely. If you make the right choice, they will stay with you for a lifetime. To get awards, you cannot just wait. You have to make it happen. You find a way around it, above it, underneath. You find a way to get on the other side. Never give up. For women, don't, men will try themselves maybe doing it. Don't hesitate to be focused and to take a few years of your life and to be focused on your goals.
Lucky for me, I had my own lab, so I was able to do this anyway. At the Mount Sinai Medical Center in New York, she did her early work. She got a bachelor's degree, I should say, from Tel Aviv University in Israel, followed by a PhD degree from the University in Miami in Florida. After a postdoctoral fellowship at Brookhaven, Dr. Goldstein has been publishing a lot of outstanding papers on the neuroimaging and neuropsychology of addiction. Several of her papers have been quoted or cited more than 1,000 times. And on Google Scholar, her impact index is very high. So I think you're going to really experience a real treat this afternoon. And I'll open the floor to Dr. Goldstein.
Thank you so much for a lovely, lovely introduction, making me blush. And thank you very much for the invitation to give a talk about my own personal journey, emphasizing the interplay between that and the actual science. It was no small challenge. So it will be very unusual to my usual focus on just science itself. And feel free to interrupt me at any time and to ask questions or clarifications, etc. Okay? Can you see my slides okay? Can you hear everything is fine, working well? Okay. Okay, so our charge was to talk about our own journey into where we are now, into our neuroscience of addiction, going as far as back as we can and highlighting things early on in our career that helped us get to where we are with some advice to people who are just starting their own journey. So that was the focus of and the charge on us in this series. So let me share with you some details of my path. I was born in Lithuania, and my early memories are all about food, or a lot of it, and about nature. And this is a cake that's very characteristic of Lithuania. It's called chakotis, and it's after these little trees that are created from this amazing blend of butter and a lot of eggs, and then roasted over fire, like you roast a little animal, basically. And then a lot of memories have to do also with just being able to eat from nature. A lot of different types of berries. I have a lot of memories there. And then basically I immigrate, that's a picture from those times. I immigrated to Israel with my family. And there, again, I have a lot of memories about nature. And this time I grew up in Ashdod in Israel, and it's a sea town. So the ocean was an extremely important part of my life. Same for sand dunes. We spent whole days basically swimming in the sand and just playing in sand. And those are wonderful memories of independence and exploration without any parental supervision or any adults around us. And then also eating figs from fig trees, which is those type of beautiful, amazing trees were just outside of our apartment. And that's a picture from actually 1 year after I arrived to New York. So from Israel, then my journey brought me to the US. In the US, we actually landed not in New York first, but in Memphis, Tennessee, And that was a huge cultural shock, the second one after Lithuania to Israel, and then Israel to Memphis. And as soon as I learned how to drive a car, I didn't need to do that back in Israel. Even as being as a student, Tel Aviv is a very busy city. You can always either walk or take a bus or anything like that. So I immediately learned how to drive a car. And 2 weeks into it, I drove myself over the railroad tracks to Memphis State University, saying, here I am, and registering to take classes in the psychology department. I had a degree, a BA, a bachelor's degree in psychology from Tel Aviv. And they introduced me immediately to other Israelis around. And I was very fortunate to be introduced to people who were running labs in neuropsychology. That's where I started learning first about neuropsychology. My training was very basic psychology about Freud and personality theories, and also a lot of statistics in Tel Aviv. And so then I started learning about manual tracings of brain areas using MR images. That was very much instrumental when we moved then to Miami. And that type of volunteering, I did that on a volunteering basis in Memphis State University. But I was able to then start acquiring this budding type of skill with those manual tracings that were very essential for me to find another volunteering type of job. I just went, again, here I am. I'm here to volunteer. And I found a neuropsychological clinic in the medical center of Miami. And that helped me then find my first paying job as a research assistant based on those manual tracings I learned in Memphis State. And I was able to then start doing some actual research projects and collecting data from charts. I was accepted, I started working in the neurology department in the medical center there, being introduced to child epileptology treatment, including neurosurgery. And that was an amazing opportunity to learn about the brain and very applicable type of research questions. And that helped me, that volunteering position in neuropsych, but also working as an RA, a paid one, and doing actual research, helped me a lot getting into the PhD department in University of Miami. And it didn't happen the first time around. It happened the second time I tried. And only after came and I showed them, here is a manuscript I'm working on based on the research I'm already conducting. And indeed, my first authorship paper came from work I already started doing before I became a PhD student. And I completed my PhD in health clinical psychology in the University of Miami. At that time, it was among the fewest programs that allowed full-blown training in both clinical psychology, so actually treating patients, people who need mental health services, and doing 100% research. So basically, we were working 200% as a graduate student. Most of you know the experience. Okay, then my life brought me to Long Island, and there I did my internship in neuropsychology to finish my PhD in that health clinical psychology. And as soon as I finished that, I was looking for a postdoc position. And I was very lucky to have already a couple of offers in Manhattan. And then I was told, okay, it's time for you to meet Nora Volkov. But before I talk a little bit about Nora, I want to mention that in addition to your PhD advisors and people who advise you as part of your formal training, it's invaluable to have mentors that are outside type of mentors. And I'm going to mention just a couple. That's Naftali Raz. At that time, he was the neuropsychologist I met at Memphis State University. And he taught me a lot about brain imaging and neuropsychology. And he's been my mentor, lifelong mentor. And also Rachel Tomer, who I met in the University of Miami when I was volunteering in that neuropsychological clinic. And both of them are very dear friends and lifelong mentors. I consulted with them on every major step in my professional career, the big type of decisions of moving to an institute or of accepting a certain very responsible role. I listened to them always extremely carefully, and not always follow their advice, sometimes doing the exact opposite. But clearly, they had a lot of amazing advice, and they are still very important in my life. So then I heard about Nora Volkov, who's doing imaging studies in addiction using positron emission tomography. I saw the amount of publications she had. It was before Googling, but I saw the immense amount of work she's already done. And when I came to BNL, Brookhaven National Lab, I expected this very established, older, serious type of person. And then I met Nora. And that was another life-changing experience for me. And Nora is very well accomplished. She's running NIDA now for many years now. She received many, many awards. I cannot even mention a couple of them. And she was managing the group there together with Joanna Fowler, who is another extremely well-accomplished scientist, really a phenomenal person. Here she's receiving the Presidential Award for Science, Technology, and Innovation from Barack Obama. And I can talk about Nora for hours, maybe days, but we don't have enough time for that. So I just want to mention her ability to share knowledge extremely generously. Her immense knowledge and the ability to share the inner workings of her extremely curious mind online while she's thinking. She's telling you what she's thinking and how she's thinking and why she's thinking and what does it mean and what is inspiring and where is she, and she has huge amount of energy. So it is a very, very inspirational. It's the experience of meeting her, knowing her, and being and really absorbing from who she is. It's just phenomenal. If you have the chance, definitely pursue it. She doesn't have much time. But another thing I want to mention about her is her mentorship ability. And she mentored us, and in a way that is, again, something that established a lifelong relationship that I cherish very, very much, a deep relationship and friendship. And I really have a lot of admiration to her and appreciation of her brain and just who she is. And this is in the context of this group that we worked in at Brookhaven National Lab. And this is myself here, and Nelly Alia Klein, whom I'm going to talk about in a minute. And this is the whole of the PET group, the positron emission tomography group. And that's how we worked. So we were a huge group. Nora and Joanna were able to mentor this huge group of people of diverse professional backgrounds. You have here people from radiochemistry and computational and modeling and MR physics and biochemistry, you name it, biomedical engineering. And they were able to do it in this most collaborative and non-hierarchical way that really establishes relationship. And there are many people here who all seem happy, and it's very genuine. And those are very established people in terms of science. Anat Biegon, Jean Logan, Kongwu Du, Elizabeth Caparelli, Dardo Tomasi, who I'm going to mention, Jinja Kwang. There are many people, too many, David Schleier, too many to mention. But this really, the first 2 years being as a postdoc and then doing there becoming an assistant professor and going up the ladder, in that environment was the most protected time that I don't know if I appreciated as much how well we were protected, loved, and cared for. And that the competition, the type of competition that is not pleasant, was not there. We definitely felt we all worked for the same reasons, for the same goals. Everybody had a different role, and everybody just was complementary, essential, and helpful to each other. I learned huge amounts in that group, and that's what we adopted, Nelly and I, Nelly Elia Klein and I, that we're now managing together our own group for many, many years now. And this is our most recent picture, but with the time of the COVID, there are a few more people who just joined the lab. Okay, so that was basically an introduction to the science, and I want to show you just a little bit of what our lab is doing and our focus on neuroimaging in drug addiction, where because we are clinical psychologists by training, we constantly think about clinical application and the possibility to use our data for intervention purposes. So just a little bit of statistics, and also to emphasize, this talk has to emphasize not only the personal journey, but also addiction neuroscience, and not just science and neuroscience in general. So this is my focus. Most people use drugs. And this is just last year use of drugs if a person is above the age of 12. And you can see that almost 14% of the US population has used marijuana. Marijuana is #1 drug. Of course, alcohol is not here. Alcohol would be off the chart. So those are the illicit drug use. So 14% of people in the US are using marijuana if they're above the age of 12. And in our lab, we have focused on cocaine, the stimulant, and about 2% of the US population has used it in the past year. Now, addiction has a lot of beauty. I'll mention a few things that are really beautiful in my mind. One is the changing nature, the constant changing nature of what happens out there in the field. So you have suddenly new drugs, spiked marijuana, or suddenly all drugs that become a new problem. And here's a pandemic that happened with heroin before our actually current pandemic, where heroin past use basically jumped in 2016. And you can see that almost more than twofold increase over 2002 in the amount of people who are using it, but a sixfold increase in the number of deaths. So many more people are actually dying from heroin. It cannot be explained by just more people are using. And this is, again, because of probably fentanyl and the new type of ingredients in heroin. And you can see the dynamic nature if you look at, for example, here I'm focusing not just on people who are using it, but people with use disorder. And I'll talk about that in a minute. And over time, these are years 2002 all the way until 16. And you can see how the percent of those with heroin use disorder is increasing, especially in the age group of 18 to 25. And clearly, it doesn't match the cocaine use disorder. People with cocaine use disorder that peaked here in 2005-06, and it is now coming down, but it's still very high up there. And cocaine is still #1 drug in terms of the admissions to emergency department visits. So if you look at people who are admitted to emergency departments, you will see that cocaine is #1 in the rates of ED visits per 100,000 in the population, more than heroin, PCP, and other type of drugs. So when people think about the heroin epidemic, clearly it's there, clearly it's lethal, it's extremely dangerous. Other drugs are also lethal and dangerous, and we have to do something about it all. And nowadays, with the COVID, if anything, there are spikes in overdoses and deaths that we need to track and to intervene in a timely way. Okay, but so the dynamic nature of addiction clearly is a very interesting phenomena that we need to study, and we need to constantly be on the alert of what's going on. And then everybody that you talk with, everybody thinks they know exactly what addiction is, because everybody knows somebody who has used drugs, or they use drugs. They have a lot of experience maybe with drug use. Maybe they are still using. Everybody has bad habits. Everybody has some histories, or they know people who have histories. And if they're not using drugs after they use the massive amounts, then it means it's under control, right? It means that it's not a disease. It's just something, okay, now you do it, now you don't. And but then to really drill the message that addiction is a disorder of the brain, a person has to understand that it's the only disorder that is accompanied by loss of control over drug use, amount or frequency of use, despite catastrophic consequences to the person's life, to things that they really, really value, and despite a decrease in pleasure derived from the drug. And this type of constellation characterizes only drug addiction. It is not just our own bad habits. It's not just using drugs. It's not even just being dependent on the drug. And we can talk about that later if you have questions. And so we all can learn about addiction And we all think we know about it because maybe we struggle with it, maybe our loved ones struggle with it, maybe we treat people who struggle with it, and we can read books about people who struggle with this, and it affects anybody. It can affect anybody, and it affects people who are just brilliant. For here, I just gave a few examples of just some of the books I read through my life, and I really, really enjoyed and learned a lot from those type of books, telling your own idiosyncratic process, and then when you put it all together, you see some clear commonalities. And this is Anthony Kiedis, the band leader of Red Hot Chili Peppers. I don't know if anybody is a rock fan. It's a wonderful book, very, very insightful. And then there is a journalist who is as brilliant, and again, describing an amazing story with alcoholism and anorexia. And William Burroughs, who is a very accomplished writer, I'm sure many of you know. So read those and many, many other books to understand the phenomenology of addiction. Okay, so then when I joined Brookhaven National Lab, meeting Nora on a regular basis, and her telling, we were talking about a lot about the brain, and I was reading, I was trying to understand what addiction was, coming from the classical more psychology and neuropsychology and schizophrenia and TBI and epilepsy, and learning about drug addiction, supplementing my knowledge from actual scientific research that's talking about addiction as a chronically relapsing brain disorder that's characterized by drug self-reinforcement, intense craving, binge episodes or entire loss of control over drug use, and then withdrawal symptoms that can be so severe as to bring a person back to drug use despite the best of intentions. And it's a chronically relapsing again and again cycle. And trying to understand this phenomena and coming with a background in cognitive in psychology and in neuropsychology, and talking about with Nora about the prefrontal cortex and about the orbitofrontal cortex, about dopamine and reward processing and reward prediction error. And it became clear that we are, in the animal studies and what happened in the literature then, there was not a sufficient focus on this type of higher order cognitive functions in attempting to understand drug addiction. Reward processing, attention to drug-related cues, automatic type of responding, that permeated the literature, especially the animal literature where addiction was studied as response to the immediate administration of a drug. And the focus was on the striatum and how that dopamine is released for acute drug administration, which was very important and informative. And then in our review of the literature and talking about what does the prefrontal cortex, where does it come to play in addiction and the subregions of the prefrontal cortex, we started to organize this type of understanding and principles around what emerged as a mechanistic type of approach, thinking about impairments in response inhibition and salience attribution that we call the ERISA model. Basically assuming that the salience and the value of drug-related reward and cues become completely overblown, and it comes at the expense of other non-drug-related reward, and with a concomitant decrease in the ability to inhibit behavior, especially in this type of a drug-related context. So, and then highlighting roles of the prefrontal cortex, orbitofrontal cortex in reinforcement learning, rostral cingulate, dorsal cingulate, so different regions in the PFC and how they relate to these specific impairments. So enhancing the view of addiction beyond that focus on reward processing to a higher order cognitive function, to really understand how is addiction different from just those bad habits, drug abuse and drug dependence, into loss of control despite catastrophic consequences, despite a decrease in pleasure derived from the drug. And I know that this model is very simplistic. You can maybe fit it with 2, maybe 3 parameters, and the brain does not work with 3 parameters, not even with 100. And the more probably the better for robust fit. But in a way, it was very influential. It's very highly cited since. And I think it was because we crystallized the importance of those specific parameters and connected them to the ability to understand addiction. I wanted to say something else, but okay, it will come back to me later. Okay, so moving along, we were very lucky, both at Brookhaven National Lab and also at when I moved to Mount Sinai, very lucky to have the ability to use many different imaging modalities. And we are very multidisciplinary in many ways, both in the ability to use the right tool for the right question in terms of the imaging modality we use, but also in terms of the comprehensiveness of our approach. And where we are, many people who are doing imaging are focusing on the behavior during the imaging itself, which is wonderful. Being a clinical psychologist and a neuropsychologist in my background, if a person is there in the lab, we're going to test everything we can. And that means we are doing hours of clinical interviewing and cognitive testing, neuropsych tests. We're very interested in this higher order cognitive functions in language and memory and personality and emotion, and how it all links then to the brain imaging data. And I'll show you some examples of that. Our subjects are cocaine-addicted individuals who are smoking crack cocaine for about 20 years, about 4 days a week. Most of them are males, and I'm going to get back to this point at the end of the talk. Most of them are African-American, in their 40s, high school level of education, average intellectual functioning. They represent the northeast urban area, basically, of New York. And we match them with healthy control subjects unless we study variables that are part of the phenomenology of addiction itself, which is other drug use, like cigarette smoking, which is much higher in people who are cocaine addicted, and also other mental health issues. So we either study those specifically or we try to statistically control for it. Now the recruitment effort is the big effort in the lab. We use flyers, word of mouth, newspaper advertisements, but we also established a whole network of collaborations with a lot of treatment facilities and organizations. And this type of establishing this network is really essential to the type of work we do, because these are where our subjects reside or come to get some treatment. And we have a lot of places like that. And it is absolutely essential, especially for any test-retest type of studies, any follow-up, longitudinal type of studies. Okay, so we have in the lab, we have several underlying hypotheses. I'm not going to be able to review them all, but I'll try to go through a few of them. One is that the PFC is impacted in addiction and that it's associated with cognitive impairment. Now it sounds clear. Of course, it did not sound as clear before. And here is an MRI, structural MRI. This is a study not from our lab, but it beautifully summarizes a lot of results, and it's a reliable, replicable result across many different labs, many different products of abuse, and showing that if you compare the gray matter, this is using voxel-based morphometry. I'm not going to get into scientific detail in this talk because it's really going to be too long, but you can ask me after the talk. So if you compare healthy control subjects and individuals addicted to any type of substance use, you have decreases in gray matter in the region of the PFC that we call the ventromedial PFC. And the important thing is that those decreases are correlated with decision-making. So the lower the gray matter in this brain region here, the worse is the performance on the Iowa gambling task. I don't know if you know this task, but it basically assesses the ability to choose the correct cards. And correct cards it means that you will choose a reward that is lower now and not larger, because you are trying to avoid a loss. So you're trying to make the right decision to manage your income, basically. And if you choose the larger reward, which is more appealing, you will lose at the end of this game. So it means that people with addiction show this type of gray matter decrements, decreases in the brain, in this brain region that is extremely important to the ability to make the right decision, the right choice on the simple gambling task. But we think that this type of ability to make the right choice underlies their inability to make the right choice outside the lab and ending up doing drugs again and again and again, even when they're trying to abstain, or making the same mistake of going back to the same place where they know they'll do drugs instead of going to the right place where they will be able to avoid the drugs. So this is Nelly Aglia-Klein. You saw her, and I mentioned her before. And this is, I wanted to show this as an example of what we find in our own lab, but also the workings of the lab. So at the time that we collected this data, we were actually focused very much, and it was at Brookhaven National Lab, on fMRI studies. This was our foray in the fMRI and the functioning of the brain, and how all this cognitive function, the PFC, etc., shows itself in the iris and these impairments in response inhibition, salience attribution in drug addiction. And then Nelly says, wait, we're getting the structural images to make our fMRI better for basically analytic purposes, because we need it and because we need to rule out gross morphological abnormalities, etc. Why don't we treat it as a source of data? Why don't we actually look at it? And not only that, we have all these subjects. Why don't we take a blood sample from them? And I remember this suggestion to be completely completely from the back of my brain, basically. I was thinking about behavior, function, and Nelly was saying, wait, a person doesn't just function. They need the morphology of the brain to function. They have a genetic predisposition, and we can actually measure it. And then we basically went for that, and then we showed that decrement in the OFC in people with cocaine addiction as compared to healthy control subjects. And Nelly showed the correlation now with lifetime years of use. So the lower the gray matter, the longer the lifetime cocaine use. And other brain regions like the hippocampus showed correlation not just with cocaine, but also with cigarette smoking and with alcohol use. And it was modulated by the monoaminoxidase A gene that Nelly targeted specifically because of her interest in aggression. And this type of correlations are really, they drive us to attribute causality. When we see that, we want to say, oh, okay, so using cocaine makes you lose gray matter in the OFC, smoking or alcohol use, etc. And we have to avoid that pitfall. Okay, so this is in no way allowing us to attribute causality, because maybe there are predisposing factors. Maybe a person who has some vulnerability, who has the certain gene allele, or childhood maltreatment that we showed also contributes to those decrements, and that happens before they ever become addicted, or nicotine smoking in utero. So we know some predisposing factors that then relate to a person's risk for addiction and risk for relapse. So we cannot attribute causality. It still means that if we curtail the length of use, we may be able to offer some protection. But then a way to go around this causality issue, which is really important in human imaging, any human imaging, is in this way. And here we did a study where we did Test and Rita. So those are the same cocaine addicted subjects that we scan at baseline 3 weeks after detoxification, and 6 months later, during a time that they are mostly abstinent. There is a clear decrease, significant decrease in drug use. And we showed that with 6 months abstinence, there is a recovery in the gray matter in the same brain regions. And not only there is a recovery in gray matter, in the actual integrity of those regions that are so essential for our decision-making and value attribution and many other functions, but when we measure function outside the lab, we see the same recovery. So this is the Iowa gambling test that I explained before. And this is a detox 3 weeks later, and this is 6 months later. So you have a recovery of a decision-making in people with addiction who are abstinent for 6 months. And there were correlations with another executive function task. So again, cannot still attribute causality. However, we're getting close. It means we are taking away the drug and we are seeing this type of changes. The ability to decrease the hesitation to attribute causality came from a non-human primate study conducted by Charlie Bradbury, now at NIDA, who gave cocaine to non-human primates who did not use any cocaine before, showing decrements with cocaine in the same brain regions, and then showing increases in gray matter and function 2 years after abstinence. And that's when I can say, okay, together those results strongly suggest that maybe cocaine itself is causing some of these detrimental effects above and beyond what a person comes with in terms of risk factors that they come in. Another story I want to tell with this slide is about Mohammed Parvez. And so basically, my husband is a biomedical engineer. He's a professor in Stony Brook University, and he's also managing his own lab. And there are many, many benefits to having a scientist as a spouse, many benefits. And one that I will mention now is that in my earliest days, he referred Mohammed, who was a biomedical engineering student then, and he was looking for a PhD lab, and he referred him to us. And Mohammed ended doing his PhD with us and staying for a postdoc, and now he has his own lab as an assistant professor at Mount Sinai, and it has been, despite our complete diverse professional and cultural background, it has been one of the most productive, pleasant, and fun relationships that I had with a person. I can mention other people, and maybe I'll mention them a little bit later, but it's definitely something to highlight. Okay, so going back, so we were not only doing those new things and out of the box type of thinking. It's also important to use the skills you have acquired, right, in your BA or PhD or whatever. And I came with those tools of, okay, statistics and neuroscience. So let's look at the data. Let's take all the data Nora and Joanna collected over the years, and let's calculate those Z-scores. I wanted to know, is there cognitive impairment in drug-addicted individuals? And what's the severity of that impairment? It was not out there in the literature. And we had cocaine-addicted individuals, people with alcohol addiction, calculating their severity of impairment as compared to this mean of controls, that here is the mean of 0, across tasks of visual memory, verbal knowledge, verbal memory, attention and executive function. And clearly, the mean level of impairment was not as severe as that reported in schizophrenia patients, and you actually have to assess for it. But it is there, it's statistically significant, and it affects their life and response to treatment. So here is a study by another group showing that the higher the global cognitive functioning, the lower the odds of attrition from treatment. It means that if we can somehow help increase cognitive function in people with addiction, maybe we can help retain them in treatment longer, and that's how we can then teach them everything we want to teach them to try to abstain from drugs or to make the right decisions at the right time. Okay, so the Rita model, the prediction is also that there's going to be increased value and salience attributed to the drug at the expense of other non-drug related rewards. That's an essential component of the Rita model. And the first study, we used event-related potential, so that's not an fMRI, and we made subjects passively look at those very pleasant images, very horrific ones, neutral images, and drug-related images. And we recorded the component that's called the late positive potential. It's a bottom-up type of component, measuring attention bias and salience of stimuli. And we compare pleasant images to neutral images, early window and late window of processing. And you can see a nice response to the pleasant images in the healthy control subjects. Similar response to the unpleasant images. The LPP does not differentiate value, differentiate arousal. It's just about salience. And then nothing for the cocaine images. So if you look at those little bags here, right? If you're not addicted, you can think, oh, they're bags of flour. Maybe some of you are aroused by flour. It didn't happen yet to me. So anyway, healthy controls were not responsive to those images. And then if you look at cocaine-addicted individuals, clearly you see the attention bias to drug-related cues. That's the first thing that jumps to you. At both the early and late time windows. And another thing that was extremely interesting in the study was that the longer they keep looking at either the pleasant images or the unpleasant images, their arousal is decreasing. As if there is a premature habituation to these non-drug related cues. And that's consistent with our hypothesis. Okay, so that's pictures. What else can assess value as well in the human culture as money? And this is our first fMRI study where we said, okay, let's try to use just monetary reward. And we were following this non-human primate study. It just came out. That was a neuroimaging study, the first one to report that you can see activations in the orbitofrontal cortex. I think it was a glucose metabolism study, showing that if you give the value of liquid or the amount of it, whether it's 2 drops or 1 drop, activates the OFC in the non-human primate. And I said, finally, now I know what to do in my first fMRI study. Let's see if I can activate the OFC with money. And because I was not interested in the primary rewards, but I was interested in more abstract, generalizable type of reinforcers, money was perfect. Money also is something you can buy the drug with. So it's as close to the drug as you can get. And we designed this very simple, following the non-human primate study, very simple go, no-go task. It was not even a go, no-go. It was just a suspend attention task and giving high money, low money, or no money. And in healthy controls, when we contrast those high money and no money, it was real money. So it added up to $50 that they got for the task. The subjects knew it. Every go and no-go, every correct response gave them money depending on the condition of the task. It added up to 50, which was half of what they made in a day. So it was valuable. In control subjects, we saw this response, including in the OFC and other brain regions, the midbrain that we anticipated. And I just want to mention here Dardo Tomasi. Dardo Tomasi, that I showed you in the second slide, an MR physicist who was instrumental to all of our imaging studies at BNL. He's just an amazingly capable person and an amazing mentor and collaborator in many different ways. He's an MR physicist. When I came to him that I want to give money and assess the value of money in fMRI, he flat out laughed at me, just really laughing hard for a few minutes. And I told him, and it's like he was laughing also anytime I reported any correlation that was 0.4, 0.5. MR physicists, if it's not 0.9998, it's not a correlation. So we had a lot of arguments standing and in the playground. We were raising kids who are best friends until nowadays. They were really, really small. So we had many hours and minutes of discussing, and he taught me a lot about MRI acquisition, analysis, even task design. And he was my best critic. And then in cocaine-addicted individuals, we didn't see this response, right? So what does it mean? Okay, I'd say it means it shows reduced response to the value of money in people who are addicted, consistent with the fact that drug value is increased, like I showed you with the ERP study, and everything else is decreased. But because I had Dardo, this was not enough. And we said, okay, let's use a completely different tool and with completely different artifacts and see if we can still see a similar result. And this is what we did. And we see again the same task, exactly the same task. And here again, this is the P300. It's very similar to the LPP, showing differentiation and increase for high money, low money, no money in control subjects and not in the healthy, in the cocaine-addicted individuals. So that's validating our first fMRI study. Another early lesson from this time is that we then said, okay, we have to look at individual differences, and not all addicted individuals are the same. So what happens if we divide into those who are positive for cocaine versus negative for cocaine in urine? Those who are positive used cocaine in the last 3 days, and we measure it. Those who are negative used cocaine 3 days and way before. And they are abstinent, basically. And lo and behold, if anything, most of the impairment is in those who are abstinent, not in those who are current users. And again, it's something that at first sight, it can evoke a response that is like, this is not real, that this cannot be, something is wrong with your data. But ever since then, you have to let data speak to you, right? Ever since then, we replicated this result, showing cognitive impairment in people who are abstinent that surpasses cognitive impairment in people who are active users, supporting the self-medication hypothesis, where people who are cocaine addicted, they're all addicted, using cocaine as stimulant to maybe normalize some of the functions. Now, there are limits to that, and we see impairments in emotional processing. So it can improve some cognitive functions, but at the expense of decreasing some other functions. Okay, how are we moving along? I want to mention another study and how we assess attention bias and the importance of words to me, coming basically because of my background as a clinical psychologist and a neuropsychologist, and the importance of tweaking tools to understand addiction. And that's, again, the beauty specifically of addiction neuroscience, and that takes it apart from other type of sciences. So here we use the emotional Stroop effect. So I showed you pictures, I showed you money. So now these are words, and words are so uniquely human. And here we changed the color word Stroop effect, and we used words, drug-related or neutral words, and the salience, we manipulated salience not only with words, but also with money. So we have 2 levels here. We're basically trying to test IRISA, and at least trying to test all of those 3 parameters, but together in the same task. I know it's still not a naturalistic type of approach, as can be, but it's trying to at least grapple with both the salience of the drug use, salience of non-drug use, at the same time when a person has to basically just respond to a conflict that's not related to either drug use or the money. They have to respond for the color of the word. They have to ignore the amount, the words or the money. And so that's what the subject did in the fMRI. And another task we took and we tweaked it, of course, because we never take things as they are, and to make it much more interesting and relevant to IRISA in addiction. And here, again, coming from neuropsych background, there is a task, a 1-minute task, that's the semantic fluency task. And if you have dementia or depression or somebody you love to have that, and you go to a neuropsychologist, that's one of the tasks they're gonna do to differentiate between depression and dementia. And they will ask you to name as many animals, for example, as you can. They can be from the ocean, house pets, the jungle, or from any other place. And basically, it's a task of initiation, set maintenance. It's a wonderful executive function task. So instead of animals or fruits and vegetables, we ask people to call to mind and name as many drug-related words as possible in 1 minute. They can be names of drugs, people, places, or states of mind related to using or recovering from drugs. And go. And that was part of our regular neuropsych battery. And healthy control subjects provided an average of 14 words, and cocaine-addicted individuals provided more. So this is in the context of this neuropsych cognitive impairment. But if you have a context that's drug-related, they cognitively perform better than healthy controls. This is their expertise. And we can also see it qualitatively. So drug-addicted individuals gave us, healthy controls gave us words that are over-the-counter drugs and derogatory terms to drug-addicted individuals. And then cocaine-addicted individuals gave us more words of paraphernalia and how to use drugs. But the important result in this study is when you combine this neuropsych extra scan measure together with what happens in the scanner. So this is quantifying that verbal fluency task, the drug words as compared to those animals and fruits and vegetables, corrected for verbal IQ. And you can see this hyperreactivity in drug-addicted individuals, cocaine-addicted individuals that you don't see in the healthy control subjects. And when you look at the brain while performing that drug Stroop task, you see the same pattern of hyperreactivity to drug words in the midbrain. And the midbrain is the place where you have the cell bodies of the neurons that produce dopamine. But if you stimulate that region, you have dopamine release in other regions like the striatum all the way to the PFC. And it's a region that is essential for any goal-directed, motivated behavior. And we actually replicated this finding. It's something in preparation with another task that has to do also with inhibitory control, not conflict, but the SSRT with drug-related words, showing the same pattern in the same brain region. So this is extremely gratifying. because it means that maybe a drug-related context that we can deploy with words, uniquely human, maybe this type of drug-related context evokes a type of process that starts something that leads to a behavior that will be automatic and that will be very hard to control outside the lab. And maybe that's what happens. This is just a marker, but maybe outside the lab, what happens is much, much worse than this. But this is a great marker now to focus on. So what do we do with all of this, now, all of these results, right? We can keep studying the ERISA and in many other drugs of addiction, in many other different ways. But both Nelly and I are compelled to do something about it. We cannot just keep studying this phenomena and not do something about it. So I'll show you, hopefully briefly, 3 approaches that we used in the lab. All work in progress, all need to be, we need more of that. One is cognitive, one is pharmacological, and one is actual brain stimulation. So cognitively, we're showing people drug neutral or unpleasant images, and then they hear a beep and they get an instruction to either keep looking at those images or decrease your emotional response to this image. So the subjects are asked to reinterpret, not just distract yourself or avoid the image, but reinterpret it. So looking at this one of a person smoking or simulating smoking crack cocaine, you can tell yourself, this is not my pipe, this is not my crack, this is a movie prop. So reappraise the situation. And then we assess attention bias. So spontaneously, you can look at any screen you wish, and we show them the images they've just seen before, which can be drug-related, neutral, or very horrible one, or a blank screen as a control. And we also get their craving responses. And we looked at gaze duration, the duration of time spent looking at one cue over another, to assess attention bias, and cognitive reappraisal strategies have been shown to reduce gaze duration to salient stimuli in health. So what happens in our addicted individuals? This was an ERP study. We did that while a person had those electrodes on the scalp. We're measuring the LPP that I mentioned before. So everybody follows the instruction to decrease their emotional arousal, and the LPP is reduced in both healthy controls and cocaine-addicted individuals with the instruction to decrease response. Great, so everybody follows our instructions. That was very pleasing to see. However, the real result is in the gaze duration screen, because there we did not instruct anybody to do anything. We just tell them, you decide, you look at where you want to look at, you do what you want to do. So this is spontaneous, uninstructed gaze duration, showing a decrease in the individuals with the cocaine use disorder in gaze duration, the time that they spend looking at the cocaine images after they reappraise them. So I think it's a very important result, because it means that maybe this type of cognitive reappraisal exercise can affect outside of the lab behavior, attention bias, which is very automatic and very hard to control. But here we're controlling it, we're reducing it with cognitive methods, with cognitive reappraisal. How long will it last? Can we actually make it into a real training that has an effect over actual drug use? We have to still do a lot of work to answer those questions. Okay, then drug addiction is chronically relapsing. People die from it. It's a horrible disease to have. We cannot have only one method to offer people who are trying to abstain. It will be a disservice, especially with cocaine, where you don't have any approved medication. So here we use methylphenidate, a dopamine agonist. It blocks dopamine transporters. It increases extracellular dopamine, similarly to cocaine itself, slower. And it increases the salience of food stimuli or math tasks in healthy individuals by bolstering cognitive functions. And the thought is that it improves signal-to-noise ratio, optimizing activity of the brain regions that are actually needed to perform the task. And methylphenidate, which is Ritalin, we give that to kids with ADHD. and it improves cognitive function and behavior in people, in children who actually need it. It does not cause a high, and it does not have an addiction potential for the people who need it. If anything, it protects people from developing addiction. Oral methylphenidate decreases, although it's a stimulant, decreases risk-taking while improving inhibitory control in other psychopathologies that impact prefrontal cortex integrity and function, frontotemporal dementia, ADHD that I mentioned, traumatic brain injury, and stroke. So our hypothesis was that methylphenidate will improve brain and behavioral function in cocaine-addicted individuals if it's administered at a low oral dose in combination with a lab challenge. And it's not that far out, because interference with binding of a drug to a target or slower pharmacokinetics, which is what we have here, is valuable in the management of heroin addiction and nicotine addiction. So back to the drug strip that I showed you before, the drug wars and the money and all the good stuff. Behaviorally, there were no differences between cocaine-addicted individuals and healthy controls performing this task. None. Matched performance, matched engagement in the task, matched anything, basically, high-functioning individuals. And still, we saw a huge amount of differences in how the brain responded to this task, including in the ventromedial PFC that I mentioned and the dorsal cingulate that I mentioned too. And here in cocaine-addicted individuals, as compared to controls, in the dorsal cingulate, you have a decrease in responding to this task, and a decrease also in the VMPFC, so important for emotion regulation. So then in another study, another cohort of subjects where we randomized and people got, it's placebo-controlled study. People are getting either oral methylphenidate or placebo. They don't know which is what. It's the same looking pill. They cannot report, they cannot guess what it is they're getting, and it's 1 week apart. And they're performing this task. And again, at placebo, you see this decrease in this brain region here, the dorsal cingulate with placebo. And that decrease is no longer there with methylphenidate one-time oral dose. Same for the VMPFC. You can see the decrease at placebo, and it's no longer there with methylphenidate. And it also was correlated with reduction in commission errors, a marker of impulsivity. Okay, so then thinking about all these different ways, and suddenly, as luck has it, and my life has been extremely, extremely lucky, as you can see. And another biomedical engineer approaches me, Lucas Parra from CCNY, City College, New York, and says, Rita, we have this TDCS device. It showed reduction in craving in cocaine addiction. Why don't you try it? And it decreases this. It's a device that sends a small direct current across the scalp to modulate brain function, inducing polarity-dependent alterations of cortical excitability. And they're designing this device to be used eventually remotely for home use. And up to now, it has been shown to reduce symptoms, motor symptoms in Parkinson's disease, decreases pain sensitivity in chronic pain patients, and indeed, preliminary evidence across labs shows it decreases craving in cigarette smoking, marijuana, alcohol, and food craving in healthy subjects. And this is the stimulation of the dorsolateral PFC. And then there is a study from Esther Nakamura Palacios from Brazil, who happened to invite me to give a talk in beautiful Vitoria a few years earlier than this, showing that in a randomized sham-controlled study with cocaine-addicted individuals who are inpatients, 5 sessions of DLPFC, of the TDCS, over the DLPFC with the anodal stimulating electrode over the right DLPFC and the cathodal one over the left DLPFC, reduced craving in those people after 5 sessions. And you can see it both here and here. So then we said, okay, the DLPFC, that's a wonderful region. Of course, I spoke a lot about the VMPFC and the cingulate, but let's take a look at the DLPFC. And this is a review, a very, very standardized, structured approach to the literature. We reviewed 105 fMRI studies in drug-addicted individuals at high level of threshold to be included in this review. And we show, consistent with IRISA across many labs, that in a drug-related exposure context, you have increases of signal, fMRI bold, in those regions, including the executive network that includes the DLPFC. But if you look at anything that's non-drug related context, you have decreases in those regions, including in the DLPFC. And in our own fMRI studies, abnormalities in the DLPFC were clearly seen in cognitive control tasks, the color words troop I didn't show you, the emotional SSRT I mentioned before, and we see a rescue with methylphenidate, and that's published results. So here another postdoc, Pierre Olivier, took the lead over this study that we set to replicate Esther Nakamura Palacios results, but this time administering TDCS 15 times, because we really are thinking about home use, repeated home use remotely. And here over 5 weeks, 3 times a week, we administered right DLPFC nodal and cathodal on the left. And we do a lot of assessments before, a lot of after, and 14 subjects completed the whole 15 sessions. And we did show a decrease in craving, but it's a trend. And we would need 15 subjects, a group, and not what we have now, which is 14 total. So we are actually, we just received the good news that we are maybe getting phase 2 resources to do this phase 2 study, where we will combine not only TDCS, the same exact study, but we can combine ERPs and reappraisal, because we think that combining TDCS during cognitive reappraisal, this is when we will get the real result a person can take home. But we need to still study this. And we had some other great effects on sleepiness, daytime sleepiness, and contemplation of change, the ability to think alternatively about your drug use and actually see yourself maybe being able to change. That may be functions of the DLPFC we need to study that. So I'm 3 slides away. I have a summary slide, an advice slide, a story of 2 slides, the grants, I'm sorry, and then our group picture. Okay, you're good to go for 5 more minutes? 7 minutes, okay. Okay, so to summarize this research part, I spoke a lot about Rita, our model, our 3-factor model, that we need some computational approaches to explore it in big databases, maybe, putting all this data together. I showed you attention bias to drug-related cues. We measure it with both ERPs and fMRI studies. I showed cognitive impairment in decision-making, global cognitive function, and also awareness of choice that I did not show you, because it will take too much time. But I wanted to say that when I came fresh from my neuropsych training, all disorders, psychiatric, neurological disorders I can think about, schizophrenia and TBI and epilepsy, you name it, this limited self-awareness and insight were integral to understanding those disorders. But people were not appreciating that at all in drug addiction. Instead, drug-addicted individuals are described as they're minimizing, they're in denial, they're flat out lying. But what about self-awareness impairments that are driven by some rostral cingulate impairments in function and structure, which is, we have a whole series of studies supporting that people with addiction have, at least half of them have clear detrimental. So I showed you cognitive impairment, association with PFC, integrity and function. I spoke about chronicity of use, about how abstinence alone can improve structure and function. I didn't show you the functional increases, but those are published. There is a recovery of hedonic processing after 6 months. I showed you that cognitive reappraisal reduces drug-related attention bias. We still have a lot to do. Methylphenidate enhances the PFC. I showed you during drugs troop, but we have evidence for it also during cognitive reappraisal, during color words troop, that's published, and resting state connectivity, that's also published. Can it be used as a cognitive enhancer? Can we use cognitive reappraisal and methylphenidate together with TDCS? And then some people will actually be able to quit. And maybe we can then reach more people in terms of reducing drug use and giving them more control over it. So I showed you the DLPFC, the TDCS of the DLPFC, highlighting brain plasticity even in adults with chronic, decade-long use of cocaine. And showing that also neuroimaging biomarkers could be useful not just to track outcome, but maybe also to improve it if you go around it the right way. I did not talk about networks in this talk, but clearly there is no OFC alone or DLPFC alone in the brain. It's all extremely connected. We have to really understand systems in the brain and how they function, how they dynamically change real time. Okay, advice to younger generations. It's only from my experience. I hope it helps. It's based on what I told you today. If you can, choose your mentors wisely. If you made the right choice, they will stay with you for a lifetime, both as mentors and as friends. It's a wonderful experience, an enriching experience. Supplement with outside mentors. It doesn't have to be a PhD mentor or postdoc mentor. People love to mentor, and we constantly mentor each other. It's a beautiful societal human capability. Establish a working relationship with somebody who thinks opposite to you. So it's really something that, I see things this way, Nelly sees them completely opposite. So we have a view that's 360 degrees, right, at any given time. And that is so valuable. And establish a working relationship, because many times it can be it's not simple to hear that you're wrong, for example, or to hear that you should do this or the other thing while you are on your track. And say yes to ideas, projects that are completely out of your comfort zone. So I gave you an example with the voxel-based morphometry and the genetics. And another failure from that time was Nelly telling me, we have to do movies in this camera. I told her, no, we don't. And we didn't, and that was a mistake. That naturalistic type of approach, I was so focused on cognitive neuroscience, neuropsychology, having a controlled condition, I had no clue what I can do with that type of data. How can I analyze it? It was way beyond me. But the same way that we use the VBM and the genetics, you don't have to be able to do something to actually implement it in your lab. You can have collaborators to help you with aspects you yourself cannot, and it still advances science greatly. And think about doing things out of your own comfort zone. So when we learn, we change. And to be able to truly change, I think it's a very painful process. Change is painful because you have to disassemble yourself and reassemble yourself. But thinking about my life, professionally and personally, the things I value the most, and all the story, the immigration story, and many different things in my science and other, it's those times that I persisted and was able to go outside my comfort zone and stay there and maintain that discomfort and that unpleasantness and then achieve that learning and change. This is the most valuable to me in who I am and in my science too. So it's a big recommendation and it's not a simple one. It's really, really not simple. Okay, establish working collaborations with other scientists, departments, and institutes as much as you can. It really increases your ability to do some clinical type of science. It's never too early to start mentoring others. It's enough that you are either half a step beyond them or that you are a step on the side. You already can start mentoring. And establish and encourage diversity, collaboration, and growth within your own group. That's again something that is not trivial, and you have to put a lot of thought and effort into it. When you go to conferences, use them to establish networks of collaborators. Don't wait to be invited to symposia. Don't wait to somebody to come to you and introduce themselves to you or to get awards. You cannot just wait. You have to make it happen. And remember that failure is completely temporary, but persistence is not. It's a lifelong pursuit. And a related theme, never take no for an answer, right? Find an alternative. I always tell anybody who wants to listen, and now I have the platform, If you see a wall, you want to go through the wall, right? But you have a wall in your way, but you want to be on the other side. What do? You stop, you say, oh, shoot, I'm gonna go do something else. No, you find a way around it, above it, underneath. You find a way to get on the other side. Never, never give up. I do want to speak a little bit for women. I don't know how many of you are here in attendance. Being a woman in science, and not with some successes, you're going to be called a difficult woman at one point or another in your life, and sometimes unexpectedly, completely, because we are raised to be benevolent caretakers and to really listen and to understand and to be kind and nice, right? This is how we're raised. At least that's how I was raised. And so being difficult is not something that's very pleasant to hear. But remember that every word like that has the positive side to it. Maybe you're difficult in one person's eyes, but actually you're getting things done, and fast, maybe even. And maybe somebody can say you're defiant, but you're actually being very curious, and you're not ashamed to ask very, very basic questions, which is what makes science so amazing, that you can ask the most basic questions, and only very few people can do that. You can be called compulsive, but actually you're persevering. And egocentric, which is a horrible, horrible term for women, although men will pride themselves maybe on it. Don't hesitate to be focused and to take a few years of your life and to be focused on your goals. And even when everything you do in life will have a price to pay, anything at all. And to be focused a little bit at those times when you're most productive, and this is the time when you also have a family, it takes sacrifices and challenges, and just maintain your perseverance and focus to ask your own questions. That's my recommendation. And lastly, but not least, run. And that is just an example. You can do anything else you want. You don't have to run. Running is difficult, but find something that gives you a lot of satisfaction and achievement, a sense of accomplishment outside of your science and outside of your family. That's something only for you, that you do 100% for you. Okay, a story of two grants. So in that review that I mentioned, I want to end on the science, where we reviewed those 105 studies. You can see the variability and the diversity and the substance of use being studied, and in the cognitive function being studied. But when you look at sex, you don't see any variability at all. Only 7 of the 105 papers we reviewed that were high quality papers were powered enough to look at sex differences in drug addiction fMRI studies. It is mind-boggling. Everything I told you is not relevant to women. All of it. I don't know if women will respond the same, if they will show the same results. So, and here is the story of 2 grants. We just received now in April, in COVID times, a grant to study sex differences in cocaine addiction. It took us 7 years. I just want you to take that for a second to think about it. So we wrote this grant, and then we kept writing, resubmitting, not discussed, rejected, the score is not enough. 7 years of submission, maybe not every cycle, but definitely every year. And then methylphenidate as a cognitive enhancer, I've been working on it for 13 years, and I am still not there. We still did not give up, and we're resubmitting in October to be continued. And this is the NAR group. One of the pictures, this is when we just moved to Mount Sinai from BNL, and in 2013. This is all of the funding that we did get, and this is for of our mentees, and this is us right now, and thank you for your attention.
Thank you. This was really an outstanding talk, Rita. I really enjoyed it, especially on the stories that you told at the beginning about how you got involved in studying the neuropsychology of addiction plus using imaging. I remember a story back in the 1990s, because I'm older than you are. When I first joined the NIDA intramural program, and I was doing clinical research also, and I wanted to study cognition in cocaine and marijuana users. Many of the older white men who ran the intramural program told me that cocaine abusers and marijuana abusers had no cognitive deficits. Lucky for me, I had my own lab, so I was able to do this anyway. And then in the 2000, you started to publish some very important papers. And I'm glad that you were able to give this talk today to all of the people listening to us today. Now, I have one question for you, though. Towards the end of the talk, you started to talk about brain stimulation.
Yeah.
Have you tried anything else that wasn't really, say, electrical based approaches, that were maybe just cognitive based approaches without medications or anything therapeutic, just to see if you could manipulate the response to a treatment?
So yeah, so that cognitive reappraisal study that I showed, where we just ask people to reappraise a drug-related context, looking at the drug-related cues, and instead of just looking at it as if they would look naturally, to really reappraise it, tell themselves a story that basically makes it not as arousing for them. And that's a purely cognitive psychological mechanism that is used in CBT, for example. It's one of the main components of cognitive behavioral therapy, where you have to isolate your thoughts, and then you have to work around them and change the way you think about things. I think that's the way that we control emotions in the best way, to any type of arousing emotion, negative emotion, whether sadness, depression, or craving. That's a very, very strong negative emotion. And the only way I see to actually reduce that type of unpleasant arousal is cognitively.
Yeah, that's what I was thinking also. I would like to open the floor for further questions. Everybody, I see that we have a bunch of people listening to Dr. Goldstein. So Ahmed, do you want to start?
John, I was thinking that it would be nice if we kind of spend few minutes to just ask people who are online right now to introduce themselves. Just have an idea about, the people who are attending the talk, to kind of have an idea about where people are coming from. So at least few of them, and meanwhile, kind of asking everybody who are listening to the talk if it is possible for them to open their videos, to be able to have more interactions in the kind of the communications that we are doing together. And meanwhile, I had a kind of one question for Rita as well. You have been talking about having the right mentor for yourself. How can I, as a student, let's think that I'm a kind of a bachelor degree student, or I'm a master's kind of a student. How can I enhance my abilities in a way that I can be qualified as a candidate for your lab in the future? What are the qualifications that you like me to have, or to raise in my kind of list of things that I can do in my CV to be picked up by you for a kind of something like a future PhD student?
No, it's not even in the CV. It's the way you approach, you would approach me. If I see, for example, a generic type of email that doesn't mention anything we really do in the lab, I delete, or I respond something. I give a very, very generic response back. If somebody actually read anything about us and found us in any way that shows clear interest in what we do, that's going a long way, a long way. And then, you know, it depends on whether we're looking for somebody at this right now. Diversity of prior experience is wonderful. So I cannot say you have to have a certain experience and not another. You have to have only human-related experience, let's say, and not animal. We're not doing any type of animal work, but it's not true. Thinking about people who worked with us had so much, they had really a richness of experience, but all of them showed clear interest in specifically what we do and were very targeted in their approach when they interacted with us. So they read the paper, they knew we were doing the TDCR study, let's say they were really interested in that specific thing, or they're really interested in addiction, or in imaging, or in cognitive, or something that is relevant.
Anybody else who might have some questions? I mean, I see a lot of young faces on my computer here. Maybe I should call on some people. I can see the names. Esther Palacios, would you like to ask any question or comment? Hello? I think a lot of the people don't want to ask. Oh, okay, go ahead.
Yes.
Hi, Esther.
Hello, I'm Esther. Hi, Rita. I'm Esther Nakamura Palacios, and Rita mentioned us. Thank you for having mentioned us, our study from here. Yes, yeah. I have just to say that this is a very great talk. Kit is wonderful. I cannot say anything else. She's wonderful. Okay. I see Nelly is also here. Yeah. Hi.
Yeah. Thank you, everybody, for attending.
Okay, if I can take this chance and thank you, Rita, for your very beautiful presentation and the coherence that anyone could see, you know, across the various studies that you have been doing, like linking them together, adding to the information bit by bit, and paving the road for future investigators. And I can see that this kind of research can be translated into practice in the near future. And yes, this is Javad Fadardi, and I am interested in studying attentional bias and cognitive bias in addictive behaviors. And I have developed an application to retrain people with attentional bias to overcome their attentional bias for, you know, addictive related substances like alcohol stimulate, drug stimulate, and other sorts of stimuli that are typical in a variety of behavior with and dimension of uncontrollability. So yeah, I would probably send you an email soon to get connected and see if we can start, you know, new ideas together. If you are interested, of course, and start, you know, new line of collaboration, for which I'm very, very grateful to the organizer of this event, Hamed and Harnian, Jane, and other people who probably I don't know very much, unfortunately, but I'm very thankful. I enjoyed the talk very much, and I'm looking forward to participating in new talks and events in the future. Thank you so much again.
Thank you.
Anybody else?
So let me mention something, if I can take one more minute. That in the lab, I focused on in this talk only on drug addiction, unfortunately, because of the time, and it took me 75 minutes. It's a long talk. But really, our lab is so unique because of that complement between Nelly and I, and Nelly's focus on aggression and violence and intermittent explosive disorder is another exemplification of IRISA. So those impairments in response inhibition and salience attribution do not explain only addiction. They may explain other disorders that have to do with this loss of control over behavior in a salient context, in a way that's really not wanted, where you really lose control and you regret later on, basically. And it's chronically, and it's relapsing, and despite harm and despite severe consequences. So that ability to test those concepts, not only in addiction, but in another related disorder, I think that's another strength we have in the lab.
Okay. Can I ask a question?
Yes, please.
Yeah, sorry. This is 10:30 p.m. in Nigeria, so I'm just lying on the bed. But my question is this. Thank you very much, Dr. Rita, for this very good lecture. I was wondering to ask, you talked about bottom top and then top level processing. Do you think that in your impaired response model, I was trying to ask, could it be that problem in the prefrontal cortex could be a predisposing factor towards addiction instead of cocaine being a causative factor towards prefrontal cortex in our clinical experiences? We found out that children with neuropsychological deficit in prefrontal cortex are better disposed to addiction. So the question is it the hen before the egg, or the egg before the hen?
Yeah, it's yes. It's absolutely resounding all of the above. A person, before they start experimenting drugs, they have a certain risk profile. And I mentioned a few of the risk factors. One would be childhood maltreatment that affects the prefrontal cortex and actually is associated with reductions in the OFC. You have nicotine exposure in utero. Another risk factor that we know affects the PFC and increases the chance the person will experiment with drugs in adolescence and then will go on to become addicted. And this is in utero, where they were exposed to nicotine. Then there was, I mentioned also the non-amino oxidase A gene. And that's another thing that may predispose in interactions with the other exposures. So absolutely, a person comes in with certain risk factors, and then they start experimenting. Most people experiment with many different things. A minority of people become addicted. Maybe those who are addicted have a combination, not lethal, but a very dangerous combination of these premorbid risks. But maybe also for them, cocaine or other drugs have a more detrimental impact on their more vulnerable prefrontal cortex, for example. But we also know from those non-human studies and animal studies that exposure to drug itself, even when you completely eliminate risk factors in animals and rats and mice, you can do that. The drug itself has detrimental effects on the brain. Although, of course, in animals, the amounts that they're exposed to but even when you control for amount and dosing, etc., there is clear effect just for the drug itself too. So it's all of these come to play in some vulnerable people in the way that then increases risk for both addiction and then relapse after abstinence.
Related to what you're saying, Rita, I think the concept of cognitive reserve. So I think people who are facing with racism from the beginning of life, other traumas that can induce cognitive dysfunction, especially in the prefrontal lobe, might have less cognitive reserve. So that when they're exposed to drugs, they're more likely to become addicted than people who have full cognitive reserve.
Absolutely. And if we can protect, if we can provide protection.
Can I add something here? As Rita said, it's very good to try to have a look at one phenomenon from different angles, like having a 360 degrees. Attributing all the causes of addictive behaviors to just brain and brain functionality, I think, is not providing a full cover of the whole story. As you mentioned, what you mentioned, Valentine, I'm pronouncing, yeah. So the emotional experiences and the motivational dysfunctioning of people due to a variety of problems, which could be personal problems, family problems, problems from the society, can cause a bad state of mood and emotion and feeling. And all we know that drugs, heroin, opiums, alcohol, are shortcuts to help people manage their state of mood and affect. So dealing only with cognitive part of the story is not sufficient. We have to look into a variety of factors to have a full picture of behaviors and people decisions to make to use drugs and avoid down that path.
Rita, do you have last words that you would like to add before we close?
Thank you so much for the invitation. It was a journey for me to prepare this talk. I never gave anything remotely so personal. I hope it was not overly, and that it worked for everybody the way it was, it was intended to work. Yeah, Hamid, you wanted to say something?
Can I just ask the last question? You have lots of musical instrument on your background. I was just thinking that, are you playing them first of all, and then what do you suggest
my husband
people...
and my child, they're the musicians. I just enjoy music.
Okay, that is amazing. And what are the other things that you do to try to kind of make a balance between work and life in your life? That is, you have suggested kind of running. What are the other things that you are doing?
Well, there are music is definitely a huge component. I have to say now with the COVID, that's something I miss the most. We go a lot to listen to music in New York. It's a wonderful place. There are some clubs. I love very, very much kind of jazz, but not classical jazz, more that it's actually also musically, I like to combine influences and never just one simple track. And there is the jazz gallery and Smoke and Smalls. There is so amazing. You can hear amazing musicians. They're scientists of music. And so that's something I really miss, and I use that a lot in my normal day to balance it. Not to mention books. And life is rich, right? Family, friends, running. Running takes time. So yeah, but definitely my lab and my work is a huge part. That is very, very, it's a very satisfying part in my life.
Perfect. It seems that we have missed Jean-Luc. So Jean-Luc is, Jean-Luc here. Okay, go ahead.
I'd love to close by stating that, Rita, this was really very, very impressive as usual. I enjoyed it, and I hope that we'll see more and more papers from you. I'm sure we will. And also
we're working hard on it. All of my lab is right. Many of them are here, and everybody's working hard. We have some new people joining us. And just to mention Scott Mahler, who was another postdoc that I have a lifelong relationship with him, like with Muhammad, Anna, they've been wonderful, wonderful people to mentor and to be mentored by. He just got today his first R1. So, it's a wonderful day today with this talk and everything coming down right now together. So thank you. Thank you for making me think about my own process and making me remember even the cake in Lithuania. Thank you.
That's great. Thank you, Rita. Ahmed?
Okay.
Thank you.
So can I mention the post-survey, the post-event survey, and then we close?
Yeah, that would be nice, because we received lots of kind of emails from people that the timing is really bad for most of the people, especially those who are in Asia. So we are trying to see how can we make a balance for that. So Pandion just posted a survey on the chat space. So if you just take the survey and see what are the timing that might be better for you for the next talks, getting sure, because it seems that for many people, we are basically running the talk in something like the middle of the night. It is really hard for people to attend. So we might be able to change that in the future. Thank you very much
so the link is
for kind of doing this. It was full of joy.